Oh, good evening, class. This is Pre-Algebra, Lesson 4.1, Prime and Composite Numbers. And so hopefully you're ready to take some notes, and hopefully you remember to take your sheets home with you today, and you've got them with you, and you're able to keep up with the notes. All right, this is 4.1, Prime and Composite Numbers. Prime and Composite Numbers. Number one, a multiple of an integer is the product. The multiple of an integer is the product of that integer and any natural number. So what is a multiple? It's the product of an integer and any natural number. So remember, natural number are numbers like 1, 2, 3, 4, 5, and up, 6, 7, 8, 9, 10, etc., 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 etc. Those are your natural numbers. And of course, product, we're thinking about what operation with product, and hopefully you're thinking multiplication with product. And so maybe you'll see a question like this. Give the first 5 multiples of 2. Give the first 5 multiples of 2. Pretty simplistic thing. If you look here on the left, first one, so you're going to do 1 times 2, and you're going to get 2. Second multiple, 2 times 2, and you're going to get 4. Third multiple, 3 times 2. Fourth, 4 times 2. And 5, the fifth, 5 times 2. There are the first 5 multiples of 2. Well, the second question I ask you, give the first 6 multiples of negative 7. So this time we want the first 6. And again, I say the first 6. So the first multiple always involves 1. 1 times negative 7 is negative 1. Second multiple, 2 times negative 7, negative 14. Third multiple, 3 times negative 7 is negative 21. Fourth multiple, 4 times negative 7 is negative 28. And then negative 35. And finally, 6 times negative 7. And hopefully you're thinking negative 42. All right, multiples. Not a big deal. It's simply a natural number, what you would think of as your counting numbers, times any other number gives you a multiple. Okay? Next idea, number 2. A factor of an integer blanks an integer with no remainder. A factor of an integer, and the key here is divides. A factor of an integer divides an integer with no remainder. Okay, this is how you can tell if something's a factor. I'll explain a little bit more what it means in a minute here. But a factor of an integer divides an integer with no remainder. So if you look at our first example here, is 3 a factor of 108? Well, we can figure out if 3 is a factor of 108 by dividing the 3 into the 108. So let's divide the 3 into the 108. So long division, you guys know how to do it. 3 goes into 10 3 times. 3 times 3 is 9. Remember, we subtract. Brings down, you get a 1, bring down the 8. 3 goes in 18 6 times. 3 times 6 is 18. And look, a 0 remainder. That would tell you that, yes, 3 is a factor of 108. Now, by the way, don't forget this. You can take your 3, one of your factors of 108, times the other factor of 108 and multiply them together, and what would you get? The 108, right? The 108. Okay, second question. Is 7 a factor of 750? So again, you're going to find out simply by dividing the 750 by the 7. 7 goes into 7 once. Right? You know how to do long division. Get a 0 remainder there. Let's bring down our 5. Can 7 go into 5? No. So we're going to put a 0 up there. We're going to bring down our other 0. 7 goes into 50. How many times? 7 times. 7 times 7 is 49. Remainder of 1, that would say no. 7 is not a factor. So you can do this test for any number. If I were to ask you a question like, is 13 a factor of, let's say, 2,144? You would simply take 13 and divide it into 2,144. Okay? If I said is 17 a factor of 2,144, you would divide 17 into 2,144, etc., etc. If you want to know if any number is a factor of a larger number, divide that number into the larger number, and you'll determine whether or not it is indeed a factor. Okay, so then prime number, next thought. And again, I trust all this is review. It should be. These are all concepts that you should have had before. And so prime number. A prime number is a natural number. Remember, your natural numbers are your counting numbers, right? We're talking about 1, 2, 3, 4, 5, 6, etc., right, are your natural numbers. So a prime number is a natural number. So let me ask you this. Can a prime number be a negative number? Not technically, no. It's got to be a natural number. It's got to be a positive number, 1 or above. Is 0 a prime number? No. It's got to be 1 or above. Prime number is a natural number that is, maybe not even 1 or above, because the next word is greater than 1, that has exactly 2 positive factors, 1 and itself. So the only factors prime numbers have is 1 and themselves. And remember, we've got to be greater than 1. So is 0 a prime number? No. Is 1 a prime number? No, because 1's not greater than 1. Is negative 7 a prime number? No, because it's not greater than 1. What are the prime numbers? Let's go ahead and list them. So what would be the first prime number? And I hope you'd say 2. Because the only factors of 2 are the number 1 and the number 2 itself. Okay? Next one would be 3. 3 is a prime number. Is 4 a prime number? And hopefully you say no, because it has factors of 2 times 2. Is 5 the next number? Yes, 5 is prime. Only 1 and 5 are factors of it. Is 6 prime? Hopefully you say no. 2 times 3. Next one would be then 7. Okay, and hopefully you're thinking ahead now. Thinking about 8. Hopefully you say no. Thinking about 9. Hopefully you say no. 3 times 3. 10. Hopefully you say no. 11. Is that prime? Yes. 12 prime? No. 2 times 6 or 3 times 4. Next one, 12. I'm sorry, 13. Is 13 prime? Yes. 13 is prime. You got the idea? Can you name the next prime number? What would come after 13? What would be the next prime? And again, you should be thinking 14, 15, and keep going until you hit one that doesn't have any factors. Hopefully you got to 17. Because again, 14, 2 times 7, 15, 3 times 5, 16, 2 times 8, 4 times 4, etc. But 17, nope, just 1 and 17. All right, what's the next one? What's the next one? Hopefully you think 19. What's the next one after 19? 20, no. 21, no. 22, no. 23, right? Hopefully you thought 23. What's the next one after 23? Let me give you a second to think of that. What would be the next prime number after 23? Okay, hopefully you said 29. What's after that? 31. What's after 31? 37. Next one after 37, 38. Oh, be careful, 38. 2 times 19. Nope. 40, we know, nope. 41, oh, that's prime. 42, no. 6 times 7, 2 times 21. 43, yeah. 43 is prime. 44, no. 45, no. 46, no. 47, 47 is prime. And we'll go dot, dot, dot. There are an infinite number of prime numbers. And you can list them all if you want, but I don't think you have enough time to do that. There are the prime numbers up to 50, because 48 is not prime, 49 is not prime, and 50 is not prime. Okay? And again, there are more. We only listed some of them. Prime numbers. All right. Then we have this aspect, a natural number greater than 1 that is not a prime number. It's called a, do you know the name? It begins with a C. Is a composite number. A natural number greater than 1 that is not a prime number is called a composite number. There are an infinite number of situations here. 4 is a composite number. Why? 2 times 2, right? 2 times 2. You can look at all the prime numbers. 33 is a composite number. You know why? 3 times 11. And look, there's an infinite number of them. 40, 2 times 20. 2 times 2 times 10, etc., etc. There's all kinds of composite numbers. If it's, listen, if it's not prime, it's composite. As long as you're talking about a number greater than 1. If it's greater than 1 and it's not prime, it is composite. Greater than 1, not prime, it is composite. Okay, number 3. Number 3, let's talk about divisibility rules. Divisibility rules. These may seem simple, but believe it or not, you're going to use these a good amount. When we get into Algebra 1 and Algebra 2, you do some factoring of polynomials. You don't know what that means yet. You're going to use divisibility rules. In figuring out common denominators, divisibility rules can help. There's just numbers of situations where knowing divisibility rules helps you. So these are something that you should have memorized. All right? So again, you're going to memorize it. 2. All right, so the first 3 are very simplistic for 2. How do you know if a number is divisible by 2? Well, first off, if it's an even number, it's divisible by 2. Or if it ends in what? And hopefully you say 0, 2, 4, 6, or 8. Right? I'm not going to do any examples. It's real simplistic if a number is divisible by 2. Is it even? Meaning, does it end in 0, 2, 4, 6, or 8? Pretty simplistic. No need to show any work on something like that. If they ask you, just say yes or no. 5. Is a number divisible by 5? Again, this is a very easy one. That means it's got to end in either 5 or 0, right? Again, very simplistic. If they ask you, you don't need to show any work. Just say yes or no. All right? Does a number end in 5 or 0? If it does, it's divisible by 5. Is a number divisible by 10? Okay, with 10, it's got to end in a 0, right? Number's got to end in 0 if it's going to be divisible by 10. Otherwise, no. So those first 3, no need to show any work. They're very simplistic, very straightforward if they end in those numbers. All right, let's get to 4. For 4, do you remember the divisibility rule for 4? All right, the divisibility rule for 4 says the last blank digits are evenly divisible by 4. Do you remember how many? It's a number here. It's the last 2 digits are evenly divisible by 4. All right, be careful now. You got to remember that. It's the last 2 digits. So here for our example of 7,172, I'm going to take the last 2 digits. And I'm going to see if they are evenly divisible by 4. Okay, so 4 goes into 7 1 time. 4 goes into 32 8 times. And what's my remainder? 0, and that would be a yes. Are the last 2 digits evenly divisible by 4? Now, there is one special case. There is one special case, and that is if it ends in 0 0. Because 0 0 would be either 100, which is divisible by 4, or 200, or 300. All of these are divisible by 4, 400, 500. So if it ends in 0 0, it's going to be divisible by 4. Okay, that's a special case there with the 4. Do you know the divisibility rule for 3? All right, very important. You should know 4, you should know 3, you should know 9. For 4, the blank of the digits are evenly divisible by 3. And I would have wanted to make that red there. The sum of the digits are evenly divisible by 3. So I've got an example here of 13,000 and 2. Is it divisible by 3? So let's break down what we've got here. I've got to do the sum of the digits. That means I need 1 and the 3 and the 2, and I need to add them up. Now you can do the zeros, but it's real boring to add up 0. So I'm adding up the 1, the 3, and the 2, and I'm going to divide that by R3. So what do we get here? 1 and 3 is 4, 4 and 2 is 6, 6/3. Hey, it does divide evenly. Yes. Add up all the digits and see if they're evenly divisible by 3. That's the divisibility rule for 3. All right, one last one for 9, and it's the same situation. The sum of the digits are evenly divisible by 9. So I've got an example, 840. So I'm going to take the digits, the 8 and the 4. Again, you can add the 0 if you want, but it's boring. And is it divisible by 9? 8 and 4 is 12. Is 12 divisible by 9? And the answer is no, not evenly. So it would not be divisible by 9. Now listen, if it would have been a 3, what if I asked you, is 840 divisible by 3? You'd have said yes, because 12 is divisible by 3 if that would have been what we were doing. It wasn't, and so 9 is not. So be careful there. Just because it's divisible by 3 does not mean it's automatically divisible by 9. It's the sum of the digits have to be evenly divisible by 9. Now, let me mention one more thing here, and we're just about done. On the divisibility rules, whenever you're proving something true or false by a divisibility rule, show the work for 4. It'll look like this, right? That's what your work will look like if you're trying to show 4 is a factor. You're going to physically show the division of the last two numbers. If you're doing 9, show your work. It'll look like this. You will visibly show the summing of the digits and dividing by 3 evenly, yes or no. And if you are doing divisibility by 9, your work will look like that. Remember, on homework, I need to see the work. Do I need to see work for the other ones, 2, 5, or 10? No. But I need to see the work on 4. It'll look just like your notes. 3, just like your notes. And 9, just like your notes. Okay, that's it for today's lesson. Hope you enjoy your evening, and we'll work on some of these in class tomorrow. Have a great night.